Well, hello friends. Today we're going to implement a socket mechanism and it's called peer creds. And I was just reading about it, and it's a thing that you can ask a local socket that you control for the peer credentials, and it gives you the credentials of whatever's on the other end of your local socket. So if we are a client program connected to the Windows server, for instance, then we can ask for the peer credentials of our connection socket that goes to the Windows server, and it will tell us the PID of the Windows server and the user ID that's running it and the group ID. There's a struct for this somewhere. Ucred. Yeah, ucred. Wait, I thought this one that we got. Peer cred. GetSocket is a pointer to a ucred structure, right? So I think we're going to implement this socket option, and then we can use this in some code, because right now, whenever you connect to something, say that you connect to the protocol server, for instance, then the first thing that you do as a client is that you send over your own PID in a greeting message, and you get back the server PID, and then you also get back your client ID. Now the client ID, it's like specific to our IPC mechanism, so I think we're still going to need to send that over, but we should be able to get rid of this part of the greeting message and just use the kernel built-in mechanism for this instead, which I think would be slightly nicer. Of course, it would be cool to not have the greeting message at all, but I think at the moment we're probably going to have to keep it because the clients need to know their client IDs sometimes. But anyway, let's just jump right into it. So we'll go to local socket, and wait, I have to search for getSocket and see how the heck we implement that, because I don't remember everything. So there's a syscall where we end up here. Wait, hold on, let me just check my config. I'm just going to put it into kernel mode. Okay, so getSocket, and we just validate all the arguments, blah, blah, blah. And then we call getSocket on the socket. And then this goes here to socket. And this isn't, wait, is this virtual? It is virtual. So IPv4 socket implements its own. So we're just going to implement our own virtual override in local socket. So we'll take this and go to local socket, and I think we'll put this here, bloop. We'll save that. Wait, what kind of changes did I just make? Oh, some gross thing up there. I didn't mean to do that. Frick. Go away, changes. I just want to make a tiny little change. Okay. And then in local socket, we'll just put it here at the bottom. I already forgot what the signature was. Okay. So I guess we can just return socket, getSocket. If we can't figure out what this is, then we'll just call it the base class. What are we calling these arguments? Value and value size. Okay. So if level is SO, wait, shit, what are the levels? I don't even remember. SOL, SOL socket. I guess that's the only level that we know at the moment. So if, wait, I gotta see how this is done here. If level is not IP proto IP, okay, so here you want to do something on the IP socket level. But what's the level gonna be with peer cred? Is it SOL socket? For the impatient, the call looks like this. Dude, this guy is like, he knows his target audience. I'm not reading anything else on this page. Okay, cool. So that's what we want to do. Okay, so SOL socket is the level and peer cred is the option. So I think we will just switch on the option here. SO peer credit. Is that defined anywhere? No, okay. We will just define it here then. You get to be number 5. That's nice. Okay, and then we're gonna assume that this value pointer here is a pointer to a struct ucred, which we haven't defined anywhere. I mean, I guess we could put our own credential information in there, whatever we think that is, but this is from the kernel's perspective, so the concept of a client ID doesn't really make sense here, unless it's something that you would set sock opt on the server side. We could look into doing something like that, but as I was talking about earlier, to get rid of the greeting message entirely, you could imagine that we have like an extended credential sort of thing that the Windows server could provide for the local socket on his side, but I don't know. We'll just do this right now. So first thing is that we're going to have to validate that this pointer here has enough writable space in memory. So if current process validate write size of ucred, and we have to define the frickin' ucred somewhere. So I guess that goes here, maybe. Struct ucred. Good and pid. Look at that guy. Simple but tasteful. Put one in Unix types as well, so we can get to it from the kernel. And okay, so if we can't write to it for that many bytes, we'll just return efault. And okay, result efault. And if the value size putter, do we care about that? I forget. Oh, I forget how this works. How the heck did we do it in here? IOCuddle. No. Get sock opt. Value size of int. Well, this is we're not being a good boy here, I think. Let me just check how this works in the where the syscall is. If we validate write to the value pointer. Okay, so we've already validated a write to the value pointer for the value size. Okay, that's good. That means that we are in the clear. This almost makes me wonder if we should have a special pointer type. Once you've validated a pointer, you could imagine that we would turn it into a validated something like this, which we could then pass around, and it would protect you from accidentally using an unvalidated pointer somewhere. I'm gonna make a note of that. Random idea about validated pointers. Maybe have a validated T or similar in the kernel for user space pointers that have been validated. Because it's what's annoying here is that we're passing around just a socklet T star, right? And it's super not obvious in this context the fact that the only thing that calls this function has already validated that this is a valid address. So address validation, by the way, it's the thing that causes the efault error, or the bad address syscall fault, which just means that you're passing an address to a syscall that is not a valid address. It's not in your memory space. So null pointer, for instance, is usually a bad address. But any address that's not allocated, that's not virtual memory allocated to this process, will give you an e-fault. So that's why we always do validation of addresses when you enter into the kernel. That's the very first thing that we do usually in syscalls. So it's just a thought. But I'm not going to start digging into that hole right now, but maybe using a smart pointer for that wouldn't be such a bad idea. So anyway, then we know that the value pointer has been validated for a write up to this size. So then we need to verify that value size is actually is big enough to fit a ucred. So if value size is less than size of ucred, then return k-result. I think that's an Ian val then. I think that's what we do for this get sock up here. For the IP layer, if you ask for the TTL or the time to live value from an IPv4 socket, then if it doesn't fit, then we give you inval. So I think that's probably valid. And then we'll do ucred value is equal to, or what's the nicest way to do this? Such a, oh god, that looks so bad. Why does it look this way? I guess you normally put the break inside the scope. Yeah. This is one of those things that I always find so awkward in C++. Like, it just looks awkward to open a scope on a case label. But at the same time, if you want to have a local inside a specific case, then you have no choice. So we'll just do it this way. Creds is ucred to value. Okay, and then we'll say creds.pid is. So shit, now we need to know the other side's idea of the PID. So this is kind of interesting because a local socket is the same object in the kernel, in the client and server. So they both talk to the same object, and then the file description determines what is the role of that particular side of the socket. So here we can't actually know which side we are on. Are we on the client side or the server side, unless we have a file description. So we're going to have to pass this in actually. And then that will allow us to check the wait, what the heck is the thing that we check? We ask for the role for a given description, right? And I haven't been touching this for a while. Okay, so we ask for the role of this description, and that gives us what? I have to look this up. Okay, we get a role which is either listener, accepted, connected, or connecting. So if the role is connected or connecting, then how do we get our peer? I guess we don't store this info anywhere. Oh, we have the origin PID and the acceptor PID. Where do we store these? Oh, these are just exposed in the absolute path? Okay. So this is actually kind of similar to what we're looking for. So let's see. Get socket text description, and then based on the role, I guess we can switch on it. Accepted. This means that we're in the server, so creds PID. Wait, I'm not using this right probably. I already forgot. Oh, it's up here. If we're connected, then we need the acceptor PID, right? So we actually need more than just a PID. We're gonna need, I guess we could probably just store full ucreds here. So we'll say ucred m connector creds acceptor creds. I feel like that kind of makes sense. And then let's see. These are local socket concepts though, so let's move them to local socket. Put these somewhere here. And probably we should clean this up a little bit when we instantiate this object. So we'll just say connector creds. It's going to be, okay, just clean it up like this. And acceptor creds. So where do we actually set the acceptor normally? Acceptor PID. It's done in socket accept. Interesting. This is a little bit confusing the way that this is all set up. So what's the origin PID? The origin PID, I guess, is the one who creates the socket. Yeah, right. But this is not terribly important for us. We just care who's on the other side. So, okay, so let's set up getSockOpt so it gets the description, because that's going to require some futzing around anyway. So in most cases, we can just do nothing with it, but we still have to pass it around. Okay. Description. And there we are. So right now this will only be for getSockOpt, not for setSockOpt. But perhaps in the future we should do this for setSockOpt as well. We'll find out. Okay, so I think that covers it. And then in local socket, how do we know the creds of the other side? I guess they are saved when we established a connection. So origin PID, where were we doing that? When you accept, so this is happening in the server. But how do we know our peer? I guess the client's origin PID is our peer. So this here is the generic socket code. So this does not, this happens for both IPv4 sockets, so like TCP, UDP, all of those sockets, but also for local sockets. So it's a little bit ugly. I'm going to do something a little bit ugly now, I think. Or no, let's not do something ugly, but let's say did accept, do this, did accept client, let's say, like that. And we'll make a virtual in socket that's protected, and we'll say like virtual void did accept socket. That's the client. And then in local socket, we can override this privately. Did accept local socket, and here we'll just hold on. We'll do it. Wait. Do it right here. Local socket did accept client, and this is not the acceptor creds, but the connector creds. PID is client, origin PID, and that would be the origin UID and the origin GID. I think that makes sense. Okay, and then we'll need to stash all of those things away somewhere. Maybe we should have this in a ucred actually, or origin PID. We can actually make a ucred for this. Ah, damn it, let's just put these here. We'll just call them origin and acceptor. That simplifies the stuff. So I was thinking we could only do this in local socket and keep it outside of the IPv4 socket classes, but it's just making it unnecessarily complicated. So we don't need did accept, but instead we just say acceptor.pid is morigin.pid. So now actually we can copy over the whole credentials. So acceptor is origin. Okay, and then origin. The origin of a socket. Like this. Get so process PID, process UID, and process GID. All right. So what can we do with this now in local socket when you ask for the peer creds? So if we are in accepted sockets, that means that origin PID, but that's such a weird thing to look at because the origin PID is not the PID of our client, of our peer, or is it? I'm getting so confused. When we are accepted, then we've accepted it from origin PID. I guess when we accept a socket, what we're really accepting is a socket object that was created in the client program. Because the client process instantiates a socket by calling the socket syscall, and that creates a socket object. And then he connects that socket somewhere, and that's now a socket floating around in the connecting state in the kernel. And when the server side accepts the socket, then it's the same object being accepted, and the origin of that now connected socket is the client program. So I guess this makes sense. It's just I'm a little bit hazy on this because I haven't been looking at it for a while, but then that makes sense. So then creds is going to be morigin. Maybe we should expose these protectedly. And if role is connected, then creds is Acceptor. If we're connecting, well, then we don't have creds, right? Connecting. What do we actually say? What does this thing do? It's only possible for connected AF Unix stream sockets. Yeah. Error. Do you get inval maybe? Invalid argument passed. I feel like this is a invalid argument. Einval probably. Or maybe not con. Not connected. That feels like a valid error too here. So if it's connecting, then return. Let's do not con. And what other roles do we have? Listener. Well, if it's listener, then you can't get the peer of a listener because it doesn't have any peers. It's never going to have a peer because when you're listening, you're just listening. So that's the inval. Oosh. Okay, is that everything? Might as well say default here just for good measure. Okay. And we'll let them all fall into the default. Here we can actually just return case success. All right, so I hope that this is correct now. Oh, here we need a break here. It's a switch within a switch. I'm confused. Cool. And then I think it's time to try to make use of this from user space. So server PID. Guess we can do the Windows server. So we'll know right away if it's messed up. So we don't have to send the client PID. Don't have to get the server PID. And see if it comes over. Definitely have to change up the greet handling here. There's no client PID anymore. So instead of set client PID, we'll just do oh, I guess we don't need to do that because we'll do that when we create this connection object. And then the greet response doesn't need a PID. So in iClient connection, let's see, we have set client PID and client PID here. So we're going to get rid of this guy. And when you ask for the client PID, we'll figure that out when we start up. So how does this work? We're getting a socket here that's already ready. I think what we'll do is we'll just say client PID is, or no, get socket mclient msocket.fd sol socket so peer cred cred size of creds. Okay, and then if this returns less than 0, then we are screwed. So we'll assert not reached. Okay, and then creds. Does that work? It's pretty good. And then if this works out, then client PID is creds PID. Okay, and let's do the same thing on the server side. Or on the client side, rather. We were just on the server side. So server PID is here. We don't need set server PID anymore. But instead, wait, how does this work? After we connect, end connection connect, and then what? Oh, this blocks until we're connected. Well, that's great. Then we can just do this. Oh, frick. I already forgot. Ucred credits. Get socket. Creds. Side of creds. Server PID is creds PID. Okay. Now we shouldn't need set server PID anywhere. Ploop and ploop and ploop. Okay, so just removing these from all the different protocols, like audio server and protocol server. Okay, let's try this. All right, what did we forget? The greet response. We messed it up somewhere. Here, for instance. Don't need to do set client PID. Oh, we should search for set client PID, because we got to fix that as well. Because we don't need to do it. Okay. Okay, what did we mess up now? AS client connection, line 51. This is now unused. Boom. Cool. I guess it's the same in all of these. The greeting messages are now uninteresting. That's good. Kind of makes me think about what is the client ID actually used for in the client, but let's not worry too much about that right now. So, right, this is not how this works. We need a Socklin T. That's what it needs to look like. Okay. Because we're passing a pointer to a length here, not a length directly. Because I think that syscall is actually supposed to write out to that pointer to the length how many bytes we actually stored. So in getSockUp syscall, we should be good boys here and say value size of ucred. Okay, PS client, what did we mess up? Okay, the missing paren. All right. A lot of churn today. It's a nice change of pace, though. I feel like videos lately have been kind of lower level for a while, which is nice. And I'm happy with the direction of the IPC system, so it's good to work on that. There are some things that annoy me about the IPC system, like here, like this is so verbose, like all of this. It would be nice if you could express this function here in a less verbose way, like maybe you wouldn't need the own putter, so it would just be like disown shared buffer response. PS kind connection handle const protocol server disown shared buffer message. So it would look like that, and maybe when you respond, you could just it would have this type, so we could do like that. That would be kind of cool. I feel like that would be an improvement over this, because the own putters, they make it very verbose. And we can't use value type, like value construction like this. We have to create a heap project. But it would require some rewriting of the IPC generator. So, you know, little things like that. Like the more I work with this, the more I start to see the little annoying things and ways to make it better. Connector creds was not declared in this scope A. Well, I guess I forgot about those. Okay. Now we'll take a look at this. Ooh, very crashy. Not very good. All right, so first impression is that something does not work. So let's see what we can figure out. Get sock opt. Did that fail anywhere, by the way? Get sock. I guess we wouldn't print anything if it did. Get sock opt. How does it know that it's connected, by the way? We have is connected, returns M connected. Who sets that? So one thing I would like to know here is that, I mean, this thing would give us an error if we're not connected, but we can also assert that the socket is connected because we are assuming that. So we say client PID is creds PID. All right. Let's print out all of it. Or just a UID and PID, actually. Okay. And an iServer connection. We can dump out the server PID. I guess a lot of this is rebuilding in libGUI now, because whenever we change these classes, like the IPC classes, then anything who uses the connection to the Windows server has to be rebuilt. So it's like half of libGUI. It would be nice if less code would use it, so there would be like a funnel for all the stuff to connect to the Windows server. But right now it's kind of spread out a little bit, and then the taskbar program does a bunch of stuff as well. That's not the most important thing in the world. Wow, this full rebuild now is taking a chunky amount of time, dude. And we definitely had a bunch of failures. So client, oh, here it's a whole bunch of them. Client PID. terminal server PID is 4. Who the hell is 4? System server. Oh shit. Oh, dude. So we're creating the socket in the server, system server. But then the socket is inherited by the Windows server. So peer cred. The returned credentials are those that were in effect at the time of the call to connect. So the origin is actually, it's not, when you're creating the socket, that's not the important credentials. The important credentials are the ones that we have when we connect somewhere. Wait, so how do we know who's on the other side when we're connecting? I guess when we accept. So in socket accept, we should probably overwrite the origin, because the acceptor is not, well, the acceptor is, we can keep the origin concept, but the acceptor is not the origin of the socket. The acceptor is the current PID, current UID, and current GID. Current process. Jeez. It's like that. I think that's it. Yeah, that's it. Okay. So I'm curious to see how this looks in System Monitor. If you look at terminal, here it says local socket of terminal file descriptor number 6 connected to PID 10, which is Windows server. That makes sense. I was kind of wondering, like, is anyone connected to system servers at PID 4? But then, well, anyway, this does seem pretty reasonable now. So I think we have a decent implementation of SO peer cred. So I think we're going to commit this, but let's just look at it here. So we should probably check the socket level as well. Get sock opt. If level is not SOL socket, we'll just call it the base class right away. So we don't want to deal with it. Okay, that's good. And we can actually write this code like this. It makes it look a little bit more sensible. So if you've accepted, then the creds are the origin of the socket, because the origin of the socket is the guy who's connected to us. Right. That makes sense. And if it's a connected socket, then whoever accepted us is the peer cred. All right. Yeah. This irritating change again. I don't want to make this change now, bruh. Leave me alone, Clang format. Okay, and then here, socket CPP. I was just thinking we could write this like this instead. Looks kind of neat to do it this way. Boom. We could do the same here in accept. So auto process, current process, and then we just say process.pid. But it's kind of tidy. Okay. Origin UID. Do we have those anywhere? Origin PID. Oh, now we could actually expose more about these sockets here. Interesting. We could put a little more data in the ProcketFS. Doesn't hurt. Why don't we expose everything? At some point, we're going to have to lock down the proc file system because it's exposing way too much information about processes. Can probably have something where the files, the directory for a process would be restricted to the UID and GID of that process, or maybe just a UID actually, because probably groups shouldn't be able to read processes. Anyway. Socket. We need these as well. UID, GID. Okay. And oh, it did accept. I forgot to remove that virtual that I didn't end up using. Okay, so now a socket will have an origin and an acceptor ucred stored on it. That's cool. Okay, and I think we're good there. So let's do a make call. But I think we are able to commit this. So let's do the kernel stuff first. Kernel. Oh, we need this socket as well, actually. Okay, kernel. Add get sock opt so purecred for local sockets. This sock opt gives you the UID, GID gives you a struct with the PID UID GID of the sockets peer. Yeah, I think that's pretty good. Then we'll say that we are simplifying. This we need to get rid of this. Spam. Simplifying here the IPC system so that the greeting messages, the greeting handshake no longer needs to pass the client and server PIDs back and forth. That's pretty cool. So lib IPC, let's say, pass PIDs client server PIDs, or no, get find for PIDs using get circle. Instead of passing the PIDs back and forth in the handshake greet in a handshake greet message. Just use get sock so peer cred, not peer name. On both sides to get the same information from the kernel. Did I put peer name in the other one? No. This is a nice little simplification of the IPC protocol, although it does not get rid of the handshake, since we still have to pass the client's client ID. Pass the client ID from the server to each client, so they know how to refer to themselves. Although this might not be necessary, and we can maybe we might be able to remove get of this later on. Cool. All right. So I guess this has been a not very visual little hacking session. Let's see how this looks in System Monitor now. So I guess we don't have an interface actually for the local sockets here. Somehow, for some reason, I thought that we did, but we don't. But we can look at them in the proc file system. So we go to proc 16, and yeah, as you can see here, this directory is 777, owned by anon, but we could consider making it 700, so you couldn't even go into it if you're not anon or root. So what are we working with here? We have FD, just gives us the symlinks to these guys. Okay, so I guess we actually have to look in, I forget what this stuff is. Is it net? Local. Yeah, these are the ones. So JP local. These are all of the local sockets. JP proc net local. So here we can see all of the magical sockets, local sockets in the kernel. Not terribly interesting. Maybe it would be good to show the role here, but maybe this information shouldn't actually be exposed in this way. I'm not sure. I mean, it's probably good that it's exposed in this way for now. But yeah, okay. This works. I'm happy with this. So I think this is going to be it for today's video. So it's a very low-level technical video, I suppose, but I hope you saw something interesting nonetheless. And thank you for watching, for hanging out. And I will see you next time. Bye.